Hello world and welcome to a new episode of AskWortell. In this episode we are going to talk about threat intelligence. We will have a look at what threat intelligence is, how we can collect it and what we can do with it. But first I want to point one thing out. It's the first edition of AskWortell where we are behind this beautiful desk. That's great, guys.
Yeah, it's
cool.
great, yes.
So I'm not doing this stream alone. I'm with two experts and of course our question master. So next to me is Gijs. Gijs, can you give a quick introduction of yourself?
Yes, of course. My name is Gijs. I've been working on the Honeypots for about a year now. It has been great and I'm looking forward to do this live stream.
Great. And next to you is Lars. Lars,
Yes.
can you also introduce yourself?
Yes, my name is Lars. I've been working for the past year on the Honeypots. And I've also been working as a part-time security analyst for Wortell in the incident response process.
Cool. And of course we are handling your questions. We have our question master Maurice for that. Maurice, can you give a short introduction?
Yes, of course, Jeroen. Thank you. Hi, people. I am Maurice de Jong. I'm a developer at Wortell. And today I will handle the questions over to our experts from YouTube and Twitter. You can send those in using hashtag AskWortell on Twitter or here on YouTube using the live chat box. And of course, as always, you can win a great prize, which is the Amazon gift card of €50.
So cool. So if you want to win that prize, please send your questions using the hashtag AskWortell or the YouTube chat, and then our experts will try to answer those questions. So let's start with what is threat intelligence. Can you give a definition of what threat intelligence is, Lars?
Yes, of course. So short topics that were mentioned before by you. We're going to start off with what is threat intelligence and with the definition. So we define threat intelligence as data left by the attacker after an attack. So this could be an IP address that they used to connect to a system, a file hash from maybe malware or ransomware that they left behind on the system, a username that they use to log in with, or domain names for maybe phishing domains or whatever. Basically anything that gives us an indication that traces back to the attacker. But why do we need threat intelligence? Well, our goal is to understand how attackers are working so we can predict what they are going to try to do and adapt to this. So if we understand how attackers work and we can predict what they are going to do, we can build detections on this and if we're lucky we can identify some attacker groups.
So can you give some examples of threat intelligence?
Yes, absolutely. So here I have two examples, one where there is no threat intelligence present and one where we do have threat intelligence. So the first example, user A signs into his email account with IP 10.20.30.40. And if we don't have threat intelligence, this doesn't really say us anything. But if we have a threat intelligence database where we find this IP address malicious, we can get an alert on that. And we can get an indication that this account could be breached.
So okay, so you try to match the activity that the user is doing, or maybe the attacker, with a database of known threat intelligence indicators that you can work with.
Yes, exactly. So I have another example for you. Let's say you download a file and it gets executed on the system. It could be possible that that is a malware and that ransomware will be deployed on your system, which has the consequence that all your data will be encrypted, which is of course really bad. But if we do have threat intelligence and the file that gets downloaded is in the threat intelligence database, it can get quarantined by your antivirus, and this ransomware, which is really bad, can get prevented on your system.
Yeah, okay. So I download something from the internet, and it has, for example, a file hash, and if my antivirus or any other application that scans my computer on those threat intelligence indicators has a match, it will alert me that something bad has happened on my machine.
Exactly.
Cool.
So now we know what threat intelligence is. We can dive a bit deeper in a case that is probably known by a lot of viewers, and that is HAFNIUM. And what is HAFNIUM? HAFNIUM is assessed to be a state-sponsored advanced persistent threat from China. And they are probably most well known for the Exchange 0-day vulnerabilities that occurred in March. How does HAFNIUM operate? Well, they try to exploit internet-facing servers using legitimate open source frameworks for command and control. And what they try to do is they try to exfiltrate data, and they do this from leased virtual private servers in the United States, because who are they targeting? The targets are primarily from the United States. And since they're after exploitation of data, the targets that are likely for them to target are infectious disease researchers, law firms, higher education institutes, defense contractors, policy think tanks, NGOs, basically anything that has valuable information for them. So I also have a small demo prepared where we can go a little bit deeper into HAFNIUM and the post that the Microsoft Threat Intelligence Center, or MISTIC, has made available to the public. So I'm going to go to the post now. Oh. If I can find it, of course, proof that it's live. So if we scroll to the top of the page, we can see first where the attacks are coming from. I'm sorry, it's really live. So the post was released by the Microsoft Threat Intelligence Center in combination with the Defender Threat Intelligence Team and Microsoft 365 Security. And some topics are highlighted on this page that I want to talk about. So the technical details of the vulnerabilities that were exposed are, the most important things are that they were able to authenticate as the Exchange server. They were able to run code as the system. And if they could get access to the Exchange server, they could write files to any path on the system. And because they were able to authenticate as the Exchange server, they were able to do this. So to dive a bit deeper in the way they are trying to operate, is they try to dump LSAS process memory. From this they can extract password hashes, and they try to exfiltrate that data. They also try to export mailbox data, because the Exchange servers are for email, of course. And after that they try to deploy a reverse shell using it to open a connection. And they also were able to download Exchange offline address books. And if they have this, they are able to access the global address list, which can open the organization up to phishing. So now that we know how they attack, we can ask ourselves, can I determine if I have been compromised by this activity? Well, the first thing you want to check out is you want to check the patch levels of your server to know if your system was vulnerable or not. You want to look at the Exchange logs for indicators of compromise. So an indicator of compromise is an indicator that your system has been compromised. And Microsoft provided a couple of places where you can check for these indicators of compromise. I'm not going to dive in too deep in that, but you can look it up yourself on this thread post.
Yeah. The indicators of compromise, is that the threat intelligence?
Yes. Yes,
Okay.
It's part of the threat intelligence, along with the way they try to attack the system. So Microsoft have also released a list of indicators of compromise, which you can download and use in your own detections. But these were basically the web shells that the file hashes of the web shells that were left behind in the system. They were placed in different paths on the system, and they had the following file names. And what did Microsoft do? They, of course, made different detections for antivirus, for endpoints, so the system where you can detect, the malicious activity, and Azure Sentinel detections, which we, of course, know from the incident response process. And they also released advanced hunting queries, which more advanced analysts can use to look for malicious behavior in their systems. So if you want to check this out, you can follow the blog post. It's easy to find.
Yeah, and those web shells are really nasty things. I played around with them for another web stream.
Yes.
It is amazing what you can do, what permissions you have on an Exchange server if you succeed in putting a web shell over there. It's really harsh.
Yeah, it's scary.
Yeah.
So, continuing. Um, Now that we know that threat intelligence is important and that we really need it, you might ask yourself, how can we collect it? So the first question you might ask yourself is, why would you want to collect it yourself? Well, first of all, you want to reduce the number of false positives in your incident response process. Benefits of that is you have a better overview of what you're using since you're generating the data yourself. You're minimalizing alert fatigue for the SOC, and you can decide yourself how long this threat intelligence is valid, which also helps with minimalizing alert fatigue.
Yeah. But can you give a quick explanation of what alert fatigue is?
Yeah, sure. Alert fatigue basically means that when you get too many detections and a lot of false positives, you can imagine that if you are working incidents all day, that at some point, if you get too many incidents, you lose some sharpness and you might be starting to make mistakes.
So actually there are more alerts that need to be handled by the SOC team than the SOC team has capacity for handling.
Exactly.
Okay,
So,
good to know that.
yeah. So another benefit from collecting threat intelligence yourself is because you generate it from your own environment. For example, with Honeypots, you can get a heads up that an attack could be coming on your organization. So if you deploy these Honeypots in your own systems, then you get notified because it's an easy target for attackers. So they will try to target those systems first, and if you get an alert on that, you know that something is coming. And also, malicious activity can also get identified by your SOC analysts, which I'm going into now. After, of course, an example of why generic threat intel versus organization-specific threat intel is important. So, if we have generic threat intel, we might have the case where a user signs in from an IP address, and according to our database, this IP address is malicious. But if the conclusion is from the analyst that it's no threat or basically a false positive, then it means you've wasted effort. On the other hand, if you have organization-specific threat intel, the accuracy of this threat intel could be better because it was generated from your own systems. So, how would you collect threat intel from your incident response process? So, in a SOC you have a process, high overview, but an alert rule triggers on specific predefined logic. The analyst gets an incident assigned, it gets triaged, so the analyst is trying to find out whether the behavior is expected or malicious. And if the final verdict of the analyst states that it was in fact malicious, you can use these alert indicators as threat intelligence and use it in further detections.
Cool. Shall we have a look if there are any questions?
Yeah, sure.
Maurice, do we have any questions?
Yes, Jeroen, we got a couple of questions. One is from Frizo, and it mentions how does IOC differ from defender detections? So
What is the
if you have
difference between an
indicators of compromise?
IOC indicator and a defender detection? Good question.
Yeah, sure. So if I understand it correctly, you mean that on the system you get a detection, or yeah, I think I get it. So if you get a detection on your system, it can be from an indicator of compromise. So indicators of compromise are used in detections.
Okay. Maurice, do we have any other questions?
Okay, great. Yes, I've got a couple of questions about the same subject. It's about the threat intelligence. Well, you mentioned it yourself. You can get some premium lists, but can you specifically choose to get some threat intelligence data from Microsoft?
Yeah, sure. So Microsoft has a lot of detections built into Azure Sentinel, into Defender for Endpoint. Basically, every security product that they have their own detections, but it does not have all of the benefits. So If an attacker is targeting you as an organization and they are targeting your IP address range, then you know that they are targeting you and not just targeting any company in the world.
Yeah, and I think the question relates more to can we get a list of threat intelligence from Microsoft? As far as I know, they don't provide a big list with all the TI indicators that they see, but they have an Azure Sentinel GitHub page where they have detections for Azure Sentinel where threat intelligence is built in. And of course, as the page Lars just showed, if there is a big attack going on, they publish a page and you can find the indicators over there. And what I did, I built a PowerShell script to download those indicators and upload them into Azure Sentinel. And after this video is finished, I will put a link in the description of this video where you can find that script. Do we have any more questions, Maurice?
Yes, there's another question about the threat intelligence. So you can gather your own threat intelligence, but can you share it with others, and how can you benefit from that?
Ooh, that's a nice question. I think Gijs is going to tell more about that later. So shall we park that question? Or do you want to answer it now?
Well, I can just give a heads up. Yes, you can. The benefits of it, I mean, the more people share their threat intelligence, the more we know about threats. But the rest of it, I'll talk about it later.
Yeah. Any more questions, Maurice?
Okay, that's great. Yeah. No, not at the moment. That was the final question. Yeah, the people are anxious to know more about this. So please continue.
Is there nobody who wants to win a Amazon gift card?
Well,
Don't be shy.
I think there is.
Okay, let's go on.
Yeah, sure. So another method of collecting threat intelligence, and I think this is a really fun topic because I've been working on it for the past year. But you can deploy honeypots, and the way you're handling this is what a honeypot is. It's a vulnerable system with known vulnerabilities, and basically it's low-hanging fruit for attackers. So they're targeting these systems, and what are we doing? We are logging their activity. So what username are they trying to get into the system with? What IP addresses are they using to target the system? Types of web requests, but also payloads that they might use attacking your system. What we do with these logs, we extract threat intelligence from them. So we centralize our data, make it accessible for our detection rules, and then we build detections on it to identify malicious behavior in our own environments.
Cool. Do we have a demo of that?
I have a demo for that, yes.
Awesome.
So what I have here, I have my WSL environment running Ubuntu. And here I have a Docker container running with one of the honeypots that is actually made by Maarten Goed, our CTO. And I'm going to demo it by exploiting the honeypot and showing how we collect threat intelligence from it. So what I'm going to do is I'm going to spawn a shell in the container, and I'm going to start by listing the files in the directory. And I'm going into the logs folder, and here we see three types of logs. The log we're going to focus on is the cve.log, and this is focused on logging the use of the CVE, and the CVE stands for Common Vulnerabilities and Exposures, and it's basically what this honeypot is built for, logging that CVE. If you use cat on cve.log, we can check the inside of it. Since I've just created this container, it is empty, but we're going to make it possible to look at what an attacker is trying to do. So here I have Postman open, and what I'm going to do is I'm going to send a payload in the exploit. I'm going to send a payload in the vulnerability that is used for the honeypot, and I'm going to send it. So the request was sent, and I'm going to check again the logs. And what we see here is a really big output. And what this is base 64 encoded. And I've also, to make it more clear on what is happening on the server, Also because the honeypot is a web honeypot, it also has a web page which we can see here.
So it looks really like a normal server, right?
Yeah, it's that's what it's meant to do. It's meant to look like a real server, so attackers are really going to try to exploit it.
Okay.
And what I have here, I've already done the pre-work for us and used CyberChef to decode what they're trying to do. So what they're trying to do here is they're trying to get a reverse shell on the system. And if we Google this, then we basically come at this one-liner where we can see that they are trying to open a reverse shell, and this comment was encoded. And we can use this data as threat intelligence to understand what attackers are trying to do on the system.
Yeah. Are there any IP addresses or file hashes or things like that in the log?
Yeah, sure. What we see here is actually a local address because I'm running it on my machine locally. Sorry, this is the local address from the honeypot, and this is the local address from my Docker host. So here we can see where they are posting the HTTP request, what type of content is in it, and because I'm using Postman, also the Postman token is given with it.
Yeah, and as it is a fake machine, we can assume that normally nobody would visit these pages, and so everything that we see over here is potentially a attacker or a script kiddie doing something malicious over there.
Exactly.
Okay.
So let me go back to my presentation. That was the demo, and now you might ask yourself, we have this data, what can we do with it?
Good question. I think you were there to answer that, Gijs.
Yes, eventually. But first, I'm going to start telling more about what's going to happen with this data, because you've now explained what threat intelligence is, how we can gather it with honeypots. But I will first tell you the journey of this data from the honeypots through our threat intelligence pipeline. And this starts. There we go. This starts in a log analytics workspace. So all the data that is gathered by the honeypots, it's first centralized in case you have more than one honeypot that is live, and then it is stored in data tables inside a log analytics workspace. So it's generally great for storage, but it also has another feature which is great, and that is that it allows you to create alert rules. So as data is coming in, you can immediately utilize it automatically with those alert rules.
Yeah, what exactly do we with those alert rules?
Well, that's also a good question, and that is going to bring me to the first subsystem of the pipeline, which is the data enrichment. So we can actually extend the data that we gather from the honeypots by using the internet. So across the internet, a lot of information can actually be found to extend what you have already gathered. An example of what you can find online, for instance, is information that will help you with third-party risk assessment. You see, the data that we gather from the honeypots, it's by nature already suspicious, like you mentioned before. Someone shouldn't be there unless they're looking for something to exploit. But we can actually use the traces that they leave behind to see if third-party databases online have actually also noticed these traces to have been behaving suspiciously. Now, if that's the case, we can have greater confidence that what we have gathered is actually with malicious intent. Another example of information that you can find online, now this mostly applies to IP addresses, but you can actually find a geolocation, so a physical location on the planet that matches it. And that can, for instance, be used in dashboarding if you want to create a world map containing locations like that. But more on that later.
Yeah, so you're basically building a pipeline to enrich and enhance the data for later usage.
Exactly. So, but when doing this, it is important to not just look up the data, but actually create a mapping from what you've found additionally to what you started with, so whatever traces are left behind by the attacker. Because if you do it like this, you don't have to enrich your data multiple times if it's recurring. For instance, if someone makes a connection with a honeypot and he does it again a day later, you already have the data for his IP address, for instance, and you don't have to look it up again. A great way to actually store this mapping is inside the blob storage, because you can import that directly into your log analytics workspace. So that again works together very well. So now that we have all this data gathered from our honeypots, and we have also extended it with data we have found online, we can actually kind of model a potential indicator of compromise, right? So these indicators, they can have certain properties, obviously whatever value you catch, but also a credibility score from the risk assessment that I mentioned, an origin, the type of indicator. A lot of information can be modeled that way. And that's very well, but how should we store this? How should we store these objects that we have now created from the data, you might ask? And that's where we get to MISP. So MISP is a service that's provided, and it stands for Malware Information Sharing Platform. And it really is a great platform. It is especially designed for indicators of compromise, and it's designed to store them, but also correlate between them or share them with others. So yes, that is also a great way to share your indicators with other people. And there's actually a really big community behind it. And that is actually great, because that means that you can have access to a lot of threat intelligence from a lot of places. Now, we've already explained that sometimes you want to have your own specialized threat intelligence, but it's out there and it's available, and that's great.
Yeah. But to get back to the question that was asked earlier, I think in MISP you can create galaxies and make multiple organizations part of those galaxies, and then the servers within those galaxies are going to synchronize, right?
Yeah, so that's right, and that's one of the ways that MISP makes it so pleasant to work with indicators of compromise and actually use it in a professional setting.
Yeah, and MISP, can I install that on my laptop? Is it free or open source? Or?
Well, first of all, it's free, and it is also open source, so those are two big pros for MISP right there. You can actually install it on your laptop, but if you want to use it to its fullest potential, that will mean you have to constantly have your laptop turned on and running. So
makes sense. Yeah.
Instead, you're probably going to want to use either virtual machine or something like that. But that is also mainly the reason, probably, why it is free and why it is so accessible, because you're going to be hosting it yourself. But that also means that it is so widely used and has such a big community. So to get back at the technical part of it, we have modeled our data to potential threat indicators, and we can store them in MISP as MISP attributes. That's what they're called. So each attribute relates to a potential indicator of compromise. And you can even group these different attributes within MISP events. So how you want to group them, that completely depends on you, perhaps by source or type of indicator. You can define that yourself, but it's really useful. And the best of it is that it can all be automated as well. It has a really good automation behind it, so it's very pleasant to work with. It's really good.
I can imagine that you see a lot of IP addresses coming through with the honeypots, especially if it's internet facing.
Yeah, definitely. So they keep coming in and they're stored in the MISP instance. It's great. It really is. But we are not done from here, however, because after that. We are going to send these MISP attributes that we have created, and we're going to send it to Sentinel, because this is where we can make the best use of it. So how we do that is through a data connector that's actually provided with Azure Sentinel, and it's called the Threat Intelligence Platforms. And this uses the Microsoft Graph API to build these indicators and allows you to utilize them within Sentinel.
Okay, so you're collecting all those log in log analytics, and from there you push them into MISP. And from MISP, you are going to send them over to the Graph API, which helps ending those threat indicators end up in Azure Sentinel.
Exactly.
Yeah.
So yeah, there is one thing though. First of all, you're going to need to have some script that is going to take your content from MISP and send it to the Graph API. And also, because of the way that Microsoft authenticates all their products, especially the Graph API, you're going to have to register that application.
Okay.
But once you have done that, you have a fully fledged system, and it will go from one place
it's
to
the
other.
initial setup.
Yeah, exactly. You set it up once, and it will just work. So that's also good. Now, this whole path that the data follows, it isn't actually limited to just a single tenant. We can actually connect multiple tenants with separate Sentinel instances to this pipeline. They can even have their own honeypots for their specialized data. So, as I have said before, if you have multiple honeypots, they will be centralized within log analytics, but you can still group them accordingly within MISP. So that's another reason why MISP is so great, because it allows you to be flexible in which Sentinel instance gets which data, in case a tenant might only want specialized data, for instance, or they may want everything, but you have full direction of it because of that. There is one issue that you will run into, though, and that is there is already a large amount of details and credentials that need to be remembered and kept for a single tenant pipeline. So, for instance, like a single tenant, it will need a source honeypot identifier. It will have, if it has its own MISP event, then it will need an identifier for that as well. With the app registration I mentioned, there's a bunch of credentials that need to be stored, and that's just for one tenant. Like if it was a single tenant solution, then you could store them, perhaps some of it as environment variable, but with multiple tenants, that's just not manageable. So you have to store it somewhere, and you have to do it securely. And how we do that, that is actually with an Azure Key Vault. Simply said, an Azure Key Vault allows you to securely keep secrets, which are just strings of text. But that also means that you can put multiple values within one secret if you just format it in a JSON manner. And by doing so, you can have all the info you need grouped by for instance, each tenant, and it will be secure, it will be in a single place, and it will work uniformly. So
cool.
Yeah, that actually, the Azure Key Vault is actually essential.
It basically allows us to set up a multi-tenancy threat distribution platform.
Exactly.
Cool.
Gathering and distributing all the way. So to summarize the pipeline, we gather the data from our honeypots, we centralize the data. If we have more honeypots than one, we do. So we centralize it in log analytics, we create MISP attributes from it, store them in MISP, and then the MISP content will later on be converted to Sentinel threat indicators and sent through the Graph API to our Sentinel instance.
Awesome. Let's see if our viewers have questions about the things you guys just told me. Maurice, are there any questions?
Yes, Jeroen, there are questions. Ariana Vanover is going for the win, I guess. First question. Yeah, she is really. Do you send all the log data from the honeypot to log analytics, or do you filter it first?
I think this is...
The question was whether we send all the log data to the MISP instance, or do we filter it first, right?
Exactly.
Yeah, so the honeypot actually, they get a lot of information that we do not need to define an attribute. For instance, it could log whichever resource on a web page it may have tried to access. Now, if that is not relevant for the indicator itself, we will not put that in MISP. So essentially, we ourselves can choose whichever data that we find either from our honeypots or online that is relevant to this indicator, and we store only those things that we find interesting. We store it in MISP.
Yeah, I think that's why also log analytics comes into play, because we can filter a lot over there.
Oh yeah, definitely.
Yeah. So, do we have any other questions, Maurice?
Yeah, there was a second question from Ariana. And the other question is threat intelligence data you send to MISP public for everyone?
Not, I'll take the question. Not necessarily. By default, it is actually only for your own organization, but you do have the option to publish it. And as soon as you do that, then you will make it available for the rest of the world. So it is a choice you have to make actively, but it is very easy to do so if you wish to do so.
So you can create a galaxy in MISP, let other organizations or people join that galaxy with their MISP server, and then it will synchronize all the threat indicators that are in there.
Yes.
I hope that answers the question.
And one extra benefit to that, if you take that approach, you can actually allow other people to mention sightings of indicators that you found. So they again boost the credibility of those indicators.
Oh, that's interesting.
Yeah.
Yeah. And I think there are already a lot of open galaxies for MISP available. So if you want to join an existing galaxy, that is already possible. Do we have any other questions, Maurice?
Well, I think we can refer to a question that we had earlier. So you can make your own threat intelligence information public, but do you benefit on that on any way?
So the question is, do we benefit if we publish our threat intelligence indicators? Is that the question, Maurice?
Right. Yeah, that's it. Yes.
You don't benefit from it directly. What I did mention before is that it does allow other people to mention if they have also seen certain attributes, then it boosts the credibility of those attributes. So you are more certain that if other people see it, hey, I've encountered whatever IP address or file hash, I've encountered that as well. So then you know, okay, then that's definitely something to look out for. So that is a benefit that you could have from it. But of course, if many people share all this information with each other, it just helps the collective group in gathering a lot of threat intelligence. So the more people that share it, the more people that have access to it.
I think that's an interesting thing that you're mentioning over there, because what you see is that attackers working together in collectively building the best tools to attack all kinds of instances on the internet. But we as defenders should also work together to make a stronger defense.
Exactly. And yes, sharing threat intelligence with each other is a great way to do so.
Yeah, that's a good way to start. Does that answer the question, Maurice?
Yeah, that's definitely a great answer. And we can continue. That was the last question.
Okay, thank you so much.
All right.
I think we can continue.
Okay. Well, I have just told a lot about this whole pipeline. I will actually quickly show the relevant parts of it as well. So as I mentioned, we start in log analytics. So right here I have a log analytics workspace open. So the threat intelligence that you can get, that you gather, could look something like this. So we have an IP, a bunch of IP addresses that come from the Honeypot. We have a method that is used, a domain, etc., etc. So this actually refers back to one of the questions. Not all the data that is available here may be relevant for a indicator. But what we do now is we select the parts that are relevant, and then we're going to send it to MISP. In reality, we first like to enrich that data, but for the purpose of the demo, that's not necessary.
Makes sense.
So I am going to send it to MISP. I'm going to do that through Postman. Now, in reality, what I said is we have alert rules that do that. So this is actually done automatically, but for now I'm going to do it manually, obviously, to make the demo go more fluently. So if I now, where is my MISP? Oh, there we go.
It's all live. It proves it's live.
Exactly. So here we have a bunch of instances. This is just a test instance. And now, as you can see, I can go quickly back to the log analytics workspace as well, but these are the IP addresses that are now in MISP. So these were just created. And as you can see here, they match what we have in log analytics as well. So the next part is where it is taken from MISP, where it now resides, and it's going to be turned into threat intelligence indicators that match with the Graph API. So again, I'm going to do this manually. So I've prepared a command to do it quickly, but you can see we have created 3 indicators, and 3 of them were sent successfully. So now let's see, if we go to our Sentinel instance. Now this generally takes a while to a couple of minutes to reach Sentinel, which we can see here as well. So I will try to refresh the page once, and otherwise we will get back to it.
Yeah, that's basically the ingestion time you're dealing with.
Yeah,
It
but-
takes
yeah.
some time if you send over something to Azure Sentinel for it to show up, and it can take up to a couple of minutes depending on the resource the log is coming from.
Exactly, and it also, I've noticed, depends on how many indicators you're sending. So it may be a bit quicker with fewer indicators, but sadly they're not there yet. But perhaps we'll see them in a minute. So for now, that's going to conclude. Oh, there we go. They have arrived.
Here they are.
So now we have these three indicators that we've seen before in MISP and also in log analytics, and we can actually see that there were events created for that as well. Oh, that's the wrong query. So the first one, okay, so the events, again, there's a little bit of a delay in it. The first one has already arrived, but the next one should also come here in a couple of minutes. So basically, this is the final destination for the data that we have gathered. It's now within Sentinel, and now we can actually use it.
Cool. And how can we use it? What can we do with it?
Well, that's actually a great question, and that's going. Then, well, I can actually talk about that right off the bat, because the next part is going to be about the usage and the detection of threat intelligence. So, as we have mentioned before, the intelligence that we gather through Honeypots is actually, well, it's of course suspicious by definition, but it's also targeted at your network. It might be a script kiddie that's just fiddling around a bit, but it may actually also be someone that is going for resources within your network, and it found the honeypot. So if that's the case, then there's a good chance that you're actually going to find these indicators back within your actual network. And if that is going to happen, you will want to know about that as soon as possible. So this is why having the data reside in Sentinel is such a great benefit, because Sentinel has a lot of detection and analytics capabilities. So you can create analytics rules that whenever within your network one of these indicators is found, you will be alerted immediately. And you can even have automated responses to that when it happens. So to summarize that part, basically honeypots, they allow you to identify any indicator as being malicious, but Sentinel is what actually allows quick reaction to the event of these indicators.
That, Sentinel matches the threat indicator with something that's currently found in the logs that ingested into Azure Sentinel.
Right. So the two working together, that is actually they fulfill each other perfectly. Yeah, I can actually show a quick demo of that as well.
Yes, please.
So then we go to the next demo. First we go back to Azure Sentinel. So what I can show you before I create an analytic rule. So if we take a look at this query, what's going on here is actually basically what I just explained. We have our Azure activity, so this is everything that's going on within our actual network. But because it's in a log analytics workspace, we can join all the events that we've gathered from the honeypots on this information. So if we have Azure activity where we log IP addresses that are used for logging in, for instance, well, the honeypot is also gathering IP addresses. So what we can do is we can match the IP addresses within our threat intelligence onto any IP address that's used for logging in. And if we have only a single result turn up, that means that something that we have found to be at least suspicious, probably malicious, is now actually logging into an actual user account. Sadly, my Azure activity log, it's empty, so I have no results for this one. But yeah, you want to know this when this happens. So how do you do that? Well, you have this great tab called Analytics, and in here you can create a analytics rule. So you select a scheduled query. So that's the query that I've just shown you. Actually, I'm going to copy that. The query that I just showed you here, that is going to check whether honeypot IP addresses are occurring within the actual network. We can use that within the scheduled query, so that means that this query is going to be run on a scheduled basis, and whenever a result turns up, we want to know about that. So we give it a name. For now I'm going to just call it Demo Analytic. You can provide a tactic based on, well, what kind of tactic is the attacker using. For now I'll leave this open. Obviously you can select the severity that matches this. I'll leave it as it is for now as well. But this is the important part. Now we have to provide the rule logic, which is what we just saw. So whenever someone signed in with an IP address that matches a potential indicator of compromise, we want to know about that. And we want to know about it even if it's just one. So the alert threshold, we're going to set it whenever the result is greater than 0. If we have just one IP address that adheres to this, that's a problem and we want to know. Now, by default, it will run every 5 hours and it will look back every 5 hours. So that means you're not going to miss anything. But if you want to if you want to know about it sooner, you could turn those values down. So let's say you could also say it runs every hour, for instance, and it checks back an hour. Then you will know it sooner if it happens. So yeah, that is those are the essential parts for the analytics rules. Now, incident settings, I will skip over that for now, and we're also not going to do an automated response. But these are options that you still have available. So then we just review everything, make sure that it passes the validation test. Now we see that we have created the proper analytics rule, and we just say create, and you're ready to go. Whenever this happens, we
this
will
Sentinel
know.
instance is now able to detect things that are happening by using IP addresses that we collected by using our honeypots.
Exactly.
Awesome.
And it's really intuitive and simple, especially the last part, because obviously it's essential to be able to detect this. Otherwise, what do you do with it? And Sentinel is just great for achieving this.
Yeah, so we saw how we can use the threat intelligence in Azure Sentinel. Can we also do some dashboarding with it, Lars?
We can certainly do some dashboarding with that. We're using Grafana for our dashboarding, which I will show you right now. And the great thing about Grafana is that out of the box, it supports connections to the log analytics workspace. So we can actually build queries to detect and display this information in a way that we want to display it. So a couple of panels that I've made is at first you see the percentual activity per time slot. So this basically places the attacks in bins of 1 hour, and it basically tells us in what times the most activity is going on. Further on, we have some detections from how much activity do we have in the past 7 days, and we have that for SSH, which stands for Secure Shell. You can use this to connect remotely to a machine. And we see actually that in the past 24 hours, our Citrix honeypot has 31,000 login attempts, and our other SSRS honeypot has 11,000 attempts in the past 24 hours. They are also trying exploits. They do that 108 times a day today for Citrix, and 149 for the SSRS honeypot. So what we can see here is we can see the HTTP requests that they are trying to use on the honeypot. Which could also tell us what are they going after, and you can make these dashboards just really simple with a KQL query. So you define what you want to see, what you want to display, and you can make a nice dashboard out of it.
Cool. Can we also map all the sightings on a world map?
Yeah, sure. So what Gijs mentioned earlier is that you that you can store this data in a blob storage. So the data gets enriched, and what we do with that is we use a join function with the blob storage and an authentication mechanism in the query. And this makes it possible to us to see where attacks are originating from. And here we can see on the world map that the biggest number of attacks is coming from China, United States, and Russia. And we can also see the types of usernames they are trying to use on SSH. And you see that the most tried username is root,
So
which makes sense.
one tip for our viewers: if you are still using the username root, change it.
Yeah.
It'll make your environment much more safer.
Yes, exactly. So that's basically what I had to show for our dashboarding.
Great, awesome. So let's get back to Maurice to see if we have any questions left. Maurice, do we have
Yes,
any
we-
questions?
Yes, we have a couple of questions. It's a question again from Ariana Venover, and she asks, where can I find those public MISP galaxies?
Ooh, that's a good question. I think when you install MISP, it comes automatically with one public galaxy that you can automatically enroll with it. But do you guys have the answer?
Not exactly, actually, because I
That-
myself haven't enrolled in a Galaxy as of now. I've been mostly focused on the specialized data that we handle. But yeah, that's definitely a great thing to look up, because they are obviously a great tool to utilize threat intelligence to its fullest. So I'm sorry, I'm not quite sure
Right.
where exactly it can be found, but I am sure that it can easily be found on Google.
Yeah, let us check this after this stream, and we will put a comment below this video where you can find the public galaxies.
Yeah, sounds like a good one.
Yeah. Any other questions, Maurice?
There's another one. What honeypot are you using for the SSH logins? And a question on that is, can the honeypot show the used password?
Right now we're using the Citrix and the SSRS honeypots with SSH ports opened up, and we're using rsyslog to detect the failed login attempts. As of now, it's not possible to log the password because they are using OpenSSH. But I noticed that it's possible to actually do that if you use a cracked version of OpenSSH, or if you deploy a specific SSH honeypot.
Yes. I hope that answers the questions, Maurice.
Yeah, I guess so, yeah.
Do we have any more?
Yes, of course. It's about the threat indicators again. This one is about once a threat indicator is pushed into Sentinel, do they stay there forever, or do they automatically get removed once they are no longer relevant?
Yeah.
I think this is a question for you, Gijs.
That is actually a very good question, because it's even something that I now realize I forgot to mention. So they are not automatically deleted. You should notice that you can delete them manually, but they're not automatically deleted. However, they do have a validation period. So for me, I've set that to 2 weeks. I consider that the amount of time that our data remains relevant. And that's actually equally, it counts equally as it being deleted, just without deleting it. So as soon as those 2 weeks have passed, that data is no longer considered valid. Actually, if you even try to retrieve that data, by default, you will only get valid data in return. So yeah, a really good question. I should have mentioned that.
Okay, so we have an attribute on the table where the threat indicator is stored, which holds the data during what the indicator is valid. Do you have any more questions, Maurice?
No, that's it for now. That was the last question.
Yeah, okay.
I have an addition for the last question, because Gijs mentioned the data retention, or the validation date of for example, an IP address. The reason why you want to put a validation date on it is that an attacker could spin up a VM and perform an attack from that IP address, and after that they delete the VM, and the IP address gets assigned to another user that wants to use cloud service. And if after those 2 weeks he has already used that IP address, the attacker, and the IP now belongs to someone else, you will get an alert on that as well, and you will get a false positive.
Yeah, that's the thing where you need to find a good balance between the validation date being longer or shorter.
Exactly.
All right. So I think it's time to decide where our prize is going to, Maurice.
All right. Yeah, well, we definitely know who the winner is. That's clear. That's Ariana Vanover. So Ariana, please send a message, an email to ask@wortell.nl, so we can make sure you get your prize.
Great, awesome. So with that, I would like to end this stream. If you liked it, of course, please hit the thumbs up button. The honeypots that you demonstrated, they are on GitHub, right?
Exactly.
Yeah, you can find them on the Wortell GitHub. And I want to thank Gijs, Lars, also Maurice. And of course, I hope to see you in the next AskWortell. Bye!
Right?
Bye.